just cut it open, and you'll see these layers, these what they call cross-bedding in the dune itself. It's one of the ways to help interpret this area. That's also why the St. Peter is so white and pure. Again, this is true St. Peter sandstone right here. It's white. It should be as almost like white as snow. Think about all the quartz grains weathering back and forth. It's a barrier island, so the ocean comes in, out, in, out, in, out. The winds blow it around. Eventually what happens is you winnow out all the dirt and what's left behind are sand grains. And if you read the handout, if you take a magnifying glass to these sand grains, they're frosted, meaning that they got scratched, they got rolled around, just like you frost glass with an abrasive surface. They got rolled around back and forth so much that they're not pure like crystalline quartz, they're white quartz on the surface. They are uniform in grain size, which we talked about for fracking. That's perfect, because when you frack a rock underground, you want to pump sand into the cracks so the natural gas or oil flows through the sand. And with that uniform grain size, it allows permeability to the level they need to get the gas out. You can melt it to make glass real easily. Silicon chips. The last big contract for the quarry across the river was for NASA, and the heat shields on the bottom of the space shuttle, the tiles. You know, one of the space shuttles had a catastrophe when those tiles were lost coming into reentry. But the glass that was used to make those heat shields was quarried from this rock here north of the river. That's one of their claims to fame. All the heat tiles were made from this pure sandstone. So it's pretty heat resistant.